careful. I gotta lay this down here. Here we go. It's breathing in and out.
Phyllis is still here. Is that another one? Lock up or don't lock up? Lock up. You don't want anything.
All right, so hope everybody can hear me. I don't have any viewers, but this will go up on the YouTube link. So I'm going to go ahead and go through the review since there's nobody here. I did send out corrected links. I sent an email and also posted an announcement in Blackboard. So maybe some of you will join as I'm working through this. I know I've had some questions about the answers to some of these first questions that have to do with function and function notation. So we're going to start there. So this very first one, given f of x equals the square root of x plus 3, g of x is 2x minus 7, h of x is x squared minus 2x minus 3. And we're to find in this first one h of negative 2. So what I would do here is say h of negative 2, this is 1a, would be equal to the square root of x. Uh-oh, my pen's running out of ink already. Let me get a different pen. Okay, so the square root of x plus 3 is the h function. Oh no, actually that's f. Sorry. H of negative 2 would be equal to x squared minus 2x minus 3. I'm going to put in a negative 2 wherever there's an x. Make sure you put it in parentheses. It will make a difference. And I just go through and calculate. I get 4 plus 4 minus 3 is 8 minus 3, which is 5, which is the answer in the answer key. Okay, so there it is, number 5. Now I will go to, and 1b asks me to do g of f of x. Now this is the one that is so confusing to a lot of students. So g of f of x is what we call a composite function. I like to rewrite it as g of f of x. I think it's clearer when we write it that way. Then you have g of f of x, so you go back to your list and you find f of x. So we have g of the square root of x plus 3, because that's f of x. And then that equals g of this, and g of is 2x minus 7. So now I'm going to say, this is my x, the square root of x plus 3, so I'm going to replace the x in my g function with the square root of x plus 3, and then it's minus 7. And so that's my answer. It's just 2 times the square root of x plus 3 minus 7. And that's the answer to that problem. All right, so then we have 1c, which is f over g of 6. So again, we're replacing the x with a 6. My f function is that square root of x plus 3. So for the x, I'm going to put in a 6 plus 3. And then my g function is 2x minus 7. So 2 times 6 minus 7. I'm going to have the square root of 9 over 12 minus 7. And so we'll have 5, and that equals 3 over 5. And that's our answer to that problem. Okay, so now we're going to do 1D. There was a question about this one. We're looking for the domain of f of x and of f over g of x. Well, the domain of f of x is the square root of x plus 3. So I am going to have to make sure this is not undefined or a number, non-real number, which for square roots, that inside the square root has to be greater than or equal to 0. So that's what I'm going to do. I'm going to say x plus 3 is greater than or equal to 0, 0, minus 3 from both sides, and I have x is greater than negative 3, greater than or equal to. So I'm asked to write domain always in interval notation. Okay, so the interval notation here would be that indicates that the negative 3 is included, and it goes to infinity. So forever, infinity signs always take parentheses. All right, the question was on this next one. I want the domain of f over g of x. This is the second part of 1D. And I think the answer key is incorrect because this function would look like this. We'd have the f of x on top, so the square root of x plus 3 over the g of x, which is 2x minus 7. We have two issues here. The square root cannot have a negative, and we've already calculated that. So that's this, or an interval notation, this right here. But this cannot be 0. You cannot divide by 0. That becomes an undefined number. So we are also going to calculate 2x minus 7 is got to be not 0. So that's what I'm going to try to figure out, not 0. And now I am going to add 7 to both sides. So my 2x cannot be 7. Divide by 2. So my x cannot be 7 over 2. Now, the issue here is that that also needs to be included in your interval notation. So the domain here would be that you cannot have 7 over 2, and you can't have anything less than negative 3. So we're going to start at negative 3. We're going to go up to 7 over 2, but we're not including it. That's why we use the parentheses. That's going to be unioned with parentheses 7 over 2. So the only thing we're not including here is the 7 over 2, and that goes to infinity. And that's the way I would write that, not the way it was in the answer key. Okay, so then I go to 1E. I'm going to get another piece of paper here. So 1E, this is subtraction. This can be tricky. You've got to remember that the second polynomial has to have all the negative 1 distributed through the entire polynomial. So let's look at this. G of x is 2x minus 7. So there's my g of x. Then I'm subtracting h of x, which is x squared minus 2x minus 3. So I highly recommend you put everything in parentheses like that. You distribute the negative. So all of these signs over here are going to change. Minus x squared plus 2x plus 3. And I'm going to put this in descending degree order. So I'm going to start out with my negative x squared. I can combine the 2x and the 2x. I'll have 4x. I have a negative 7 and a positive 3 gives me a negative 4. And that's my answer. Okay? So subtraction of polynomials becomes actually addition and the opposite of this. So all those terms change their signs. Now we have 1F. Now somebody asked me what is the difference between this symbol and the little circle symbol, which I said before was a composite function. Well, this is multiplication, it's not composite. So you're just multiplying the two. So you've got h of x, which is right down here so it's clear. G of x and you multiply those out. But in this case, they're not asking for the function over x, they're asking it over -3. So I'm going to put my -3 in for my x's and just calculate. So I have 9 plus 6 minus 3 here. Here I have -6 and -7. And so I'm going to end up with 15 minus 3 is 12 times a -13. And that is actually the -156 that is in the answer key. Okay? All right. So that's 1F. Let's do 1G. Now 1G is in the Excel. So I'm going to try to bring up a screen share. Application windows. Let's see if I can do this. I should be able to. This is what I want. Give me a minute. I was going to try to pull up the Excel. Not thinking that's going to work. I think I got it here. There we go. It's always a little tricky. Okay, so you should be able to see now my Excel file. And you are taking your f of x, this is it right here, and you're putting in this formula. So go and look at this formula. That's the way you would put in a square root. You've practiced all of these in your lab. Here we have this one would be put in this way. This is your g of x. So you get your table of values and you insert your graph. And then this is the very last one. This is your h of x. So that's that one. And that's the way you would put in your formula right here. Okay. So we will come back to that when we get some more questions on that. I'm going to stop screen sharing. There we go. We're back here. All right. So the next thing is to state domain of the following functions. Express your answer using interval notation. So this is 2a. We have g of x equals 2 times the square root of x minus 5. Remember, we're just concerned about the square root can't be negative. So we're going to say it has to be greater than or equal to 0. Add the 5 to both sides and say it's greater than or equal to 5. And then what we're doing is doing it in interval notation. So greater than or equal to, so it's equal to 5, so we will have the bracket all the way to infinity, which of course takes the parentheses, and that's your answer to that one. And now we have 2b. And this one is where this down here cannot be 0, or that makes that an undefined number. So I'm going to take that and say the x minus 5 times x plus 3 cannot be 0. And I'm just going to go through and solve this. So each one of these can't be 0, because either one will make that a 0 in the denominator. So I can't have 5 and I can't have -3. And to write the interval notation for this, you will say, going from negative infinity, we always do least to greatest in interval notation. So I'm going to go negative infinity to -3, union with -3 to 5. Now notice I'm using parentheses here because we're not including the -3, we're not including the 5, and then to infinity. So it's telling me all real numbers except -3 and 5. And that's number 2. Okay, so let's get to conversions right now. And the conversions, let's see, are going to come off of that table that you have. So no, let's not forget that you'll get that with your test. You need to be familiar with that table. Okay, so the first one, we're converting 10 pounds, pounds per square foot. Okay, so this is 3A, 10 pounds per 1 square foot. And I'm converting this to kilometers over meters squared, okay? So my conversion off the table tells me 2.2 pounds equals 1 kilometer. Okay, so I'm converting my pounds first. Oops, off the screen. Sorry about that. And so my pounds are canceling. I'm putting the kilometers on top because I want it to be kilometers. But I still have to convert the feet squared. So I'm going to put feet squared on top. That's because they cancel top to bottom. And I'm going to put the meters squared on the bottom, and I'm going to look for conversion. And what I have is that 1 feet squared. Oh, this is feet, meters squared, not cubed, is 9.29 times 10 to the negative 2. And so I multiply across the top, and then I multiply this across the bottom, and I get this, and then I divide, and I get a number like this, and I round it to 48.9 kilometers per meter squared. And make sure on your test you put all your units on, because I have to take points off for not using units. Okay, and then this is the B part. We're converting now 500 kilometers per meters cubed. We're converting it to pounds per feet cubed. So I'm going to go in, I'm going to use this similar conversion of 2.2 pounds to 1 kilometer. Notice that it's reversed from up here. This is on top now. I know that because I have to put the kilograms on the bottom. It's not kilometers, it's kilograms on the bottom, and the pounds on top to convert it to pounds. And then I need to convert the meters cubed to the feet cubed. And I'm using a different conversion. I have 35.3 feet cubed to 1 meters cubed. I multiply everything across the top and across the bottom, and I get 31.16 and so on, and I round it to 31.2 pounds per feet cubed. Okay. And now 3C. C, I'm converting 28.3 newtons per meter squared. We actually have a direct conversion for newtons per meter squared to the atmospheres, the ATM. So I'm just going to put this over 1. I don't need to set it up like these two. Okay. And I can multiply it by 1 atmosphere over 1.013 times 10 to the 5th newtons per meter squared. These cancel. So when I do this math here, I will have atmospheres. And so I'm going to end up with 28.3 over the 1.013 times 10 to the 5th. And that's going to equal, if I put it in standard notation, this very small number, and I can convert that to scientific notation by moving the decimal 4 places to the right. Okay, I'm going to round it there. And when I move the decimal to the right, I'm going to get a negative exponent, and that's atmospheres. There's my unit. Okay. Let's see. The next questions what we're doing is changing scientific notation back and forth to standard. So these are a little bit easier problems. So I'm doing 3D. I'm converting this number. So that's 485,100,000. But notice this little bar above there, that indicates that's a significant digit. You do need to know your significant digits, okay? Normally that 0 along with the rest of these are not considered significant digits. But in here, this is a significant digit because they put that bar up there. And so when I convert it to my scientific notation, I take my decimal and I move it 3, 6, 7, 8 places. But that 0 is significant, so I have to put it, not the other ones, but that one. Okay? And that's times 10 to the 8th. All right, so now 3e, I want to convert 0.002300 to scientific notation. All right, these zeros are not significant. I know they need to be there to keep the place. So this is in 10,000ths place, right? So this is 23 10,000ths. However, they're not significant. But these two back here, if they're there, they're significant digits. So we're going to have to move our decimal 3 places. And it's to the right. So we're going to have the 0, 0, because they're significant, times 10 to the -3. Okay? All right, so the next one is 3f, and we're converting 7.40 times 10 to the -2 to standard, so we need to go back and we have -2, so that decimal place, so I'll make this a smaller number, right, because this is a small number. So we're going to have 0.074. That way I moved it 2 decimal places. It looks like this is a significant digit because we had it there, so we're going to have to include it. And that's the answer to 3F. All right. 3G. Oh, isn't that the one we just did? No, this one's a little different. Still 7.40 times 10 to the 3rd. So this time the is going this way, right? 740, that's 3 decimal places. However, since this was here, that's considered a significant digit. We're going to have to put that bar over that one to indicate that that 0 is a significant digit. Okay? All right. And 3H. I need to find the value of this division problem. So you can just throw that in your calculator, okay? And then give the correct units and the correct significant digits. Okay, so I'm going to, and everybody knows you got to bring your calculator to the testing, okay? You're allowed to use your calculator. So I would take my calculator and I would divide that, and I get this. And make sure you put your units in there, okay? All right, now significant digits. Let me pull a calculator out. Okay, so maybe we should just go over this a little bit more. Okay, now this is a calculator that, it's kind of hard for you guys to see the numbers. I don't know if I can make it clear or not. Apparently not. can see it a little bit, but you'll put in the problem. And so this problem is 3.77 divided by 14.43. And since you can't see that, I'm just going to write it down. Gives me 0.2612612, and it just keeps repeating. So the way that I know that this is the significant digits here is I go back to the original problem. And when you multiply or divide with significant digits, you take the one that has the least amount of significant digits. So this number right here has 3 significant digits. This number right here has 4. So I can only have 3 significant digits. So my 3 are right here, 261. Okay. All right. Now 3i. I'm trying to add all these numbers, okay? So I'm just going to put these in my calculator. So I add them all up. So I got 111.45. That has 2 decimals. When you're adding or subtracting, you're looking at how many decimals you have. So I actually get 119.175, but my decimal places is 2. So I'm going to have to round that to 2 decimal places. And so the answer is 119.18 centimeters. Make sure you put your units, always your units, okay? This one up here was meters per second. All right, so on the back side now, we got number 4. Number 4 is working with inequalities and interval notation again. So in this one, I'm just going to act like this is an equal sign here and subtract 5x from both sides. Cancels here, and I get a negative 2x minus 8 greater than 6. So these solve just like equations except for an exception, which I'm going to show you right now. So I'm going to add 8 to both sides here. We get negative 2x greater than 14. Now here's my exception. When you divide or multiply a negative number, your sign flips. Okay, so we get x is less than negative 7 here. And then to write that in interval notation, okay, least to greatest, so you start with negative infinity to 7, and you know it's 7's not included, there's no or equal sign here, so that's a parentheses as well. So that's 4a. Let's do 4b. I got negative 25 less than or equal to 2x minus 5 less than 7. Okay? All right, so these have 3 parts. You're always isolating x in the middle. So the first thing I want to do is get rid of that 5. I'm going to add it, but I'm going to add it to all 3 parts. So here I get negative 20 less than or equal to 2x less than 12. Now I divide all 3 parts by 2 because I want that x by itself. So I get negative 10 less than or equal to x less than 6. In interval notation, that's going to have a bracket because of the or equal sign, to 6, which is a parentheses because there's no or equal sign. So this is your answer to the problem. All right, and one more of these. We've got 4c, negative 8 less than or equal to 4 minus 3x minus less than 19. Again, I want the x by itself, so I'm going to subtract 4 from all three parts. I get a negative 12. The 4's cancel. I have a negative 3x in the middle. And here I have 15. Now I'm going to divide by negative 3, but what was that special rule? All my signs are going to flip because I'm dividing by a negative number. So I'm going to have a greater than or equal to and a greater than here. My negative 3's cancel, have an x in the middle. 15 divided by negative 3 is a negative 5. Negative 12 divided by a negative 3 is a positive 4. And remember that when you write your interval, it always is least to greatest, so the negative 5 is coming first. It's not included, so parentheses. The 4 then comes after, and it has a bracket. So the answer to this is all numbers between negative 5 and 4, including 4, but not including negative 5. Okay, so the next part of your review is significant digits. So I did post, I think it was in lesson 2. I'd have to go back and look, but if you look through your lessons, there's one of the lessons where you had significant digits. It might have been lesson 3, and I posted a sheet that gives you all the rules to follow. So you can go back and look at those. But if your zeros are sandwiched between significant digits, they are included as significant digits. But if they're at the end of a number for a whole number or beginning of the decimal number, they're not included. Okay, so that's mainly what you have to remember. And of course, all non-zero digits are significant. So for this first one, 485,100,000, remember this indicates a significant digit, but these down here are not significant. So we have 1, 2, 3, 4, 5 significant digits for that one. So that was 5A. 5B, we've got 0.002300. And here, all these zeros here are not significant, but when they write zeros at the back end of a decimal, those are considered significant digits. So what we have is 1, 2, 3, 4 significant digits there. And then for C, we have 0.043. Again, these are not significant, just the 4 and the 3, so there are 2 significant digits. So you need to know those for the test as well. What is left is Excel, so I'm going to bring Excel back up and just kind of quickly go through it. I don't have anybody on the broadcast, and I don't have anybody asking me questions, so I'm not sure what you guys need to know. But if you will go to your Excel, and I'm going to pull it back up on a screen share and share it. We'll go back here where we were. Okay, that was what we did here, but now here's problem number 6. So problem number 6 says, use this Excel table. So you input the table, just like I did here, okay? And then you take that table, highlight it, go to your insert chart, and do your scatter chart, right? Make sure that you label your axes and give it a title, or you're going to lose points, okay? So you got to make sure you do all that. So the easiest way to do that is to select the layout 1, which gives you, once you insert, let's see if I can pull it up here, a scatter chart. They give you these different charts. Well, that's just the chart type. But if I go here, that gives me a place to insert a title and axes labels. Okay, so that's the first one. Okay, so I can delete that off my, all right. So those are things you're going to be graded on, okay? And then we have problem number 7, which this one you just put in these formulas to calculate. Okay, so let's just look at those real quick. So here, of course, a formula always has an equal sign, and then you have the numbers on top, but notice that they're in parentheses. If you have this type of fraction or, it's actually division when you put it into Excel, you have to show what's in the numerator by putting it in parentheses so that Excel knows all that's the numerator and then all that's the denominator. So make sure you put the numerator and denominator in parentheses or you're going to get it wrong, okay? Then the next one, the key here is knowing that pi, parentheses is how you put pi in Excel, so you need to remember that. And then the rest of it's pretty self-explanatory. You've got 4 times, that's the asterisk, the pi, times 2.6 to the second power. Okay. All right. And then your last one here is square root. You have to remember that square root is written SQRT with parentheses for what's in the square root. So this plus 5.4 was not part of the square root. So make sure that you don't include that in the parentheses. And I think maybe we should go back to, problem 1, because I didn't point out that when you're putting these formulas in to put these functions in to graph them, that you're using cell references. You're not calculating this yourself. I am looking for this cell reference. Like here, my cell reference is A4. That's in place of the X. That's because this is A4. And then when I pull this down, I grab this little thing and I pull it down, it gives me the correct cell reference for each one. Like this one says A6. Some of you didn't do that on your lab and you lost points for it, and you will lose points for that on the test too. So in each one of these cases, there are cell references. Here it's referencing the A20. You're multiplying 2 times A20 minus 7. So make sure you do that. So I hope you guys get a lot out of this. I'm sorry that nobody attended. It may be the time, it may be the confusion. I had to re-upload the webcast because I was having some technical problems, but at least all of the examples are here. If you still have questions, let me know. You can post those questions on the question forum that I created for that. And I wish everybody good luck on your first test.